Hey everyone. Yes, you for sending in this wild research paper about something called the AI Scientist.
hmm
I don't know about you, but the second I saw that title, I knew we had to do a deep dive on this one. You want to know if AI can actually do science now? And honestly, so do I.
And it's not just like science fiction anymore. This paper makes some seriously bold claims. They're saying this AI doesn't just help with research, it practically RUNS the whole process from start to finish.
Right. Like, we're not just talking about analyzing data someone handed to it. This AI supposedly comes up with the research questions, designs experiments, runs them, and then it writes the whole darn paper. Is this like the end of grad school as we know it?
Well, let's not get ahead of ourselves, haha. A key difference here is that past AI projects usually focused on just one part of research. This system aims to do it all, at least in certain fields, which is where things get really interesting.
Okay, so let's break this whole thing down. The paper lays out how this AI scientist works in three main stages, all kind of mirroring how we do it as human researchers. First up, idea generation. I mean, where do we even start when we're trying to solve a problem?
They start with this basic code template, kind of related to the field, and then the AI uses these prompts in a technique they call, get this, chain of thought. What that means is they're essentially giving the AI a structured way to brainstorm.
So it's like giving the AI a trail of breadcrumbs to follow, prompting it to think, like step by step, and build on its own ideas, just like when we jot down notes to brainstorm, right?
It then does this quick search through existing research using something called the Semantic Scholar API. The AI is literally making sure it's not repeating what's already been done. It's looking for the gaps in our knowledge.
Whoa, okay. So it's not just coming up with A and Y random idea, it's trying to find something actually new. But once it has, like, a solid hypothesis, how does it actually test it? Stage 2 experiment iteration.
This is where it gets really interesting and where another AI tool comes in something called Aider. This is like a supercharged lab assistant that takes that research idea and actually designs experiments to test it. It even runs those experiments virtually and like tweaks them based on the results.
Wait, so it's not just designing the experiment on paper, it's actually like running it too, like in a simulation.
Exactly. Imagine like giving this AI a problem, say optimizing solar panel efficiency, right?
Yeah.
It could run thousands of simulations, like overnight, testing different materials, different designs, something that would take human researchers months, if not years, to do in a real-world lab.
That's where this whole AI doing science thing starts to feel very real. Okay, so you've got the AI brainstorming ideas, designing and running experiments. What's left?
The grand finale. Stage 3 is paper write-up, where the AI takes all that juicy data and generates a full-fledged scientific paper. Introduction, methodology, results. The works.
So the AI is basically trying to publish in Nature now, but the real question is, can it write a paper that's actually good?
That's what we're here to find out. And thankfully, the researchers provided several examples of AI-authored papers in their paper. They focused on machine learning, which makes sense considering the tools involved.
Okay, so let's put one of these AI-written papers under the microscope. How about this one? Dual-scale diffusion, adaptive future balancing for low-dimensional generative models. I'll admit, that title makes my brain hurt a little.
Don't worry, it's a mouthful. This paper basically dives into the world of diffusion models, which have been making waves in AI, especially for creating images.
So like those AI art generators everyone's freaking out about, is that what we're talking about here?
Yeah, exactly. Think of it this way. Imagine taking a perfectly clear picture and slowly adding noise to it, pixel by pixel, until it becomes this completely unrecognizable static. A diffusion model basically learns how to reverse that process, how to denoise the image to bring back the original picture.
Okay, that actually makes sense. So this AI-written paper, it's all about making those diffusion models work even better. What's the specific problem?
It's addressing this really tricky issue. See, these models sometimes struggle to capture both the overall structure of an image and the fine details at the same time, especially when they're dealing with, like, simpler images. Imagine an AI trying to generate a picture of a cat. It needs to get the basic shape right, but also things like the whiskers, the fur texture.
Those little details that make it look like an actual cat and not some like weird blob monster. So did the AI come up with a solution?
It did. It proposed this pretty clever approach called a dual scale method. Basically, it created two branches within the model. One that focuses on the big picture, like the outline of the cat, while the other one zooms in on the fine details, like the texture of its fur. It's like having two artists working on the same image, each specializing in different aspects.
So instead of one AI trying to do everything, it's like a team effort, each AI focusing on what it's best at.
And the really impressive part is it even created this weighting mechanism to dynamically balance the contributions of each branch throughout the entire process. So it's not just a static division of labor. The AI is constantly adjusting how much emphasis to give to each branch as it goes.
That's some seriously next-level stuff. But did it work?
That's the million-dollar question. Now, while this AI scientist shows promise, it's still got a lot to learn. Kind of like a student's first attempt at a research project, you know.
So, not quite ready to take over the lab just yet. What didn't quite work? What are the telltale signs that this was written by an AI, not a human scientist?
Well, for starters, it tends to present every single result from every single experiment it ran, even if it wasn't that important. Kind of like that student who's so excited to show their work that they forget to edit out the rough drafts.
Okay, I can see that. Enthusiasm is great, but sometimes you need to know when to cut something. Anything else?
The bibliography is a bit of a giveaway, too. While it does pull in some relevant citations, it's missing some key references that a human researcher would have almost certainly included.
So maybe that literature search isn't quite as thorough as it could be. Like, it's missing those connections that only come from, like, really deeply understanding a field.
It seems that way. The code itself is well written, which is important.
Yeah.
But there are these little quirks that kind of scream AI author.
So we've got this AI scientist. It's written a paper. It's got some good ideas, some rough edges. But the real question is, could this thing actually get published in a scientific journal?
Now that is the million-dollar question. And to get the answer, we need to delve into the fascinating world of AI peer review.
Oh boy, here we go.
So we've got this AI churning out research papers, right? But could they actually get published? That's where it gets even wilder. They didn't just make an AI to write the papers, they made one to grade them too.
Wait, seriously, an AI peer reviewer? That's some serious AI inception happening.
Exactly. The researchers wanted to see if an AI could actually judge the quality of, like, AI-generated research.
Makes sense. You wouldn't want your English teacher grading your math homework, right? So how'd they train this AI reviewer? Did they, like, make it read every scientific paper ever published?
Pretty much. Well, not every paper. But they trained it on this massive data set of actual peer reviews from, like, a top machine learning conference called NeurIPS.
So they fed it, like, the best of the best, basically. But could it actually tell good science from nonsense?
That's the big question, right? So they compared the AI reviewer to human reviewers across a bunch of different metrics. Accuracy, F1 score, something called AUC, even things like false positive and false negative rates.
Okay, hold up. I know our listeners are a smart bunch, but could you break down what those metrics actually mean in this context? Like, what are we actually measuring here?
Of course. So imagine you've got, like, a stack of papers, some good, some not so much. Accuracy basically tells you how often the AI reviewer made the right call. Did it agree with human reviewers on whether a paper was, publishable or not?
So it's not just about saying yes or no to every paper. It's about being aligned with how a human expert would judge it.
Exactly. And that's where that F1 score comes in. A high F1 score means the AI isn't just rejecting everything or being super lenient. It's like finding the actually promising research, just like a good reviewer should.
Okay, so it's about being discerning, not just like a robot rubber stamp. What about those other terms you threw out? False positives, false negatives?
Right. So a false positive is like when the AI gives a bad paper a thumbs up. It's a miss. A false negative is the opposite, right? Rejecting a paper that actually had potential. We want to see those rates, obviously.
Makes sense. So it's not enough for this AI reviewer to just have an opinion. It needs to be a good opinion, one that, like, matches up with expert judgment. How'd it do?
The results were surprisingly good. It wasn't perfect, of course. But across several of those metrics, it performed comparably to those human reviewers.
No way. So are we about to see, like, a robot uprising in the scientific publishing world?
Let's not get ahead of ourselves.
Yeah.
While these results are exciting, we have to remember this AI reviewer is still in its early stages.
Right, still learning the ropes. But it really makes you wonder, what happens as this technology improves? Could we see AI reviewers becoming commonplace? Maybe even helping to speed up the whole publishing process?
It's certainly possible. Peer review is essential, but it's also time-consuming. And, sometimes papers get stuck in limbo for ages, right? AI could definitely help streamline things, but...
There's always a but, isn't there? What are the potential, downsides here?
One big concern is bias. Remember, this AI reviewer was trained on human reviews, which, can reflect the biases of those reviewers.
So if the data it learned from had biases, the AI could end up, perpetuating those biases, even if it's not, intentional.
Precisely. And that's something that researchers are actively working on, developing ways to, mitigate bias and make AI-powered peer review as fair and impartial as possible.
So it's not just about making the AI a smarter reviewer, but a fairer one too. That's a lot to consider.
But even with these challenges, the potential here is huge. Imagine a future where AI helps us identify the most promising research more quickly, speeding up the pace of discovery itself.
That's a really exciting thought. Okay, so we've got AI scientists writing papers, AI reviewers grading them. What's next? Are we going to have AI editors making the final decisions about what gets published?
It's definitely within the realm of possibility.
This is all getting a bit meta, isn't it? AI, writing about AI, reviewing AI. It's like an AI Ouroboros, forever consuming itself.
But jokes aside, it's clear that AI is playing a bigger and bigger role in scientific publishing.
Right. It's not just about like replacing humans. It's about giving us new tools to handle like this ever-growing amount of research being done.
Exactly. AI can help us see patterns we might miss, analyze mountains of data, even come up with new research directions we haven't even considered before. It's about augmenting human intelligence, not replacing it.
Okay, so we've talked about AI writing and reviewing research, but what about the actual doing of science? Where could this AI scientist have the biggest impact in the real world?
The possibilities are honestly pretty mind-blowing. Imagine AI tackling things like drug discovery, climate change, material science, things that would take us decades to make progress on. AI might be able to do much, much faster.
So we're talking about like potentially speeding up the development of new life-saving drugs, finding solutions to climate change. AI could help us solve some of the biggest challenges facing humanity.
That's the hope. Of course, it's not a magic bullet. There will be limitations, ethical considerations, but the potential is undeniable.
Right, we don't want to get too ahead of ourselves, but it's an incredibly exciting thought. So what are some like concrete examples? Where could this AI scientist make the biggest difference?
Let's take drug discovery, for instance. Imagine an AI that can analyze these massive data sets of chemical compounds, identify promising drug candidates, even design experiments to test those candidates in, like a virtual lab.
So instead of spending years doing trial and error in a lab, we could have AI rapidly narrowing down the options, finding the most promising leads.
And it's not just limited to drug discovery, right? Think about material science, developing new materials with like very specific properties. That could revolutionize everything from energy production to construction.
So instead of relying on like accidental discoveries or painstaking trial and error, we could have AI helping us design materials with specific properties, like super strong but lightweight alloys or more efficient solar panels.
And let's not forget about climate change. AI could analyze climate models, identify tipping points, and even help us develop more effective mitigation strategies.
So AI could be like our secret weapon in the fight against climate change, analyzing data, modeling scenarios, even helping us figure out where to focus our efforts for the biggest impact.
And these are just a few examples, right? The potential applications of AI in science are vast, and honestly, they're still unfolding.
It's both exhilarating and a little bit daunting, isn't it?
But one thing's for sure, the future of science is going to look very different thanks to AI.
But before we get too carried away with all the amazing things AI could do, let's take a step back and talk about the potential downsides, too. It can't all be sunshine and roses, right? What are some of the limitations of this approach?
One of the biggest limitations right now is that AI is only as good as the data we feed it.
So if the data is like incomplete, biased, or just doesn't reflect the complexity of like the real world, the AI's conclusions are going to be flawed.
Exactly. It's like trying to bake a cake with only half the ingredients, you know? You might end up with something that like resembles a cake, but it's not going to be very good.
Right. And even if you have all the ingredients, if they're like past their expiration date, the cake's still going to be a disaster. So ensuring the quality of the data is essential.
And it's not just about the quality, it's also about the kind of data.
Right.
This AI scientist, it mainly works with data that can be coded, right? Numbers, simulations, things like that. It's not so great at dealing with like the messy, subjective aspects of research that humans are good at.
So like things like intuition, creativity, or those aha moments that come from like years of experience in a field.
And that brings us to another limitation, explainability. AI systems, especially these complex ones used in this research, can be kind of like black boxes. They give you an answer, but it's not always clear how they got there.
So it's like the AI is saying, trust me, I'm an AI, but we don't always know what logic it's using or what assumptions it's making.
And that could be a big problem, especially in fields like medicine, where understanding the why behind a decision is absolutely crucial.
It's like if an AI doctor diagnoses you with something, you'd want to know how it arrived at that conclusion, not just blindly trust its judgment.
Right. So it's not enough for the AI to just be right. We need to be able to understand its reasoning.
So we've talked about the limitations of data and explainability. Anything else we should be talking about?
Another big one is generalization. Right now, this AI scientist is really good at tackling very specific problems in very specific fields. But can it take what it's learned and apply it to, like, new unrelated problems? That's still a big open question.
So it's like it can ace a test on diffusion models, but can it, like, write a sonnet? We need to see if it can truly think outside the box, so to speak.
And that's one of the next big frontiers in AI research building systems that are not just specialized, but can adapt and learn in new, unfamiliar domains.
Okay, so we've covered a lot of ground here, from how this AI scientist works to its potential impact, as well as some of the limitations. Where do we go from here? What's the next chapter in this story?
And to answer it, we need to think even bigger beyond the technical details and consider the broader implications of AI doing science.
So we've talked about the mechanics of this AI scientist, its potential to shake up scientific publishing, even its possible real-world applications. But now let's get really big picture, shall we?
It's easy to get caught up in the nitty-gritty details, but stepping back, looking at those broader implications, that's crucial.
This isn't just about one AI writing one paper. It's about reimagining how we discover knowledge, period. What does it even mean for science if AI is in the driver's seat?
It's a question that has philosophers and scientists alike, both excited and a bit uneasy, to be honest. If we take what this research suggests, to its logical conclusion, we're talking about a potential acceleration of scientific discovery, unlike anything we've ever seen.
Imagine an AI that never sleeps, never gets tired of experimenting, and can analyze data at speeds we can barely comprehend. It's like hitting fast forward on the entire scientific process.
Think about fields like astronomy or genomics, where we're just drowning in data. An AI scientist could analyze those massive data sets, find patterns we'd never spot on our own, and generate entirely new hypotheses for us to investigate.
So it's not about replacing human scientists, but about giving us tools to tackle problems that are simply beyond our current capabilities.
Imagine this AI scientist working alongside researchers, analyzing data, suggesting experiments, maybe even sparking those aha moments that lead to groundbreaking discoveries. It could fundamentally change how we approach research,
It's a bit like how telescopes and microscopes opened up entirely new worlds to us. We didn't stop looking at the stars or studying cells. We just started seeing them in a whole new way.
I like that analogy. And it's not just about the tools themselves, right? It's about the way they change our perspective. The questions we ask, the problems we choose to tackle AI could open up entirely new avenues of scientific inquiry.
It's exciting, but it also raises some pretty big questions, doesn't it? I mean, what happens to the human element of science in all of this? The curiosity, the creativity, the passion that drives us to understand the world around us.
That's a question a lot of people are grappling with. Honestly, I don't think those things will ever go away. If anything, AI could free us up to focus on the why of science, the big questions that really matter.
It's like, instead of getting bogged down in the day-to-day grind of data analysis or running experiments, we could have AI handling those tasks, freeing us up to focus on the bigger picture, the really creative and intellectually stimulating aspects of research.
Precisely. AI could be that tireless assistant handling the tedious tasks, analyzing data, identifying patterns, while we focus on the big questions, the so what of it all.
That's a really optimistic way to look at it, but there are still those concerns we talked about earlier, right? Bias in the data, the black box problem. How do we ensure that this AI-powered science is still good science, ethical science?
Those concerns are absolutely valid, and it's not something we can just leave up to the AI to figure out. We need researchers, ethicists, policymakers, everyone working together to establish guidelines, safeguards, ethical frameworks for AI-driven research.
So it's like, as we're building these incredible AI tools, we also need to be building in the guardrails, right? Making sure we're using them responsibly and ethically.
Exactly. It's a massive task, but one that we can't afford to ignore. The future of science, and perhaps humanity itself, might depend on it.
Okay. So to wrap this all up, we started with this one research paper, The AI Scientist, and it's kind of blown our minds wide open. We've talked about AI writing papers, reviewing them, even potentially revolutionizing entire fields of science.
It's a lot to take in, that's for sure. But it's also an incredible time to be alive, witnessing the birth of a new era in scientific discovery.
It really is. A huge thank you to our listener who sent in this mind-bending paper. You've given us, and hopefully everyone listening, a lot to think about. And who knows, maybe one day soon, we'll be reading groundbreaking research papers authored not by humans, but by their AI collaborators.
Now, wouldn't that be something?
Until next time, keep those brains buzzed.